We are solving out the question related to the differential equation. Question says that solve the differential equation d cube y upon dx cube plus 3 d square y upon dx square plus 3 into dy upon dx plus y is equal to e the power minus x. Solution. Let us write down given equation can be written as given equation written as write down d by dx is equal to capital D by dx is equal to capital D. Now when we put d by dx is equal to capital D, we get d cube y. From d cube y upon dx cube, y take out as a common, then we get d cube plus 3d square plus 3d plus 1 into y is equal to e the power minus x is equal to e the power minus x. Now auxiliary equation is given by auxiliary equation in short form we can write down a. Now a is given by auxiliary equation is given by. For finding out the auxiliary equation, we put capital D is equal to m, then we get m cube plus 3m square plus 3m plus 1 is equal to 0. It's become m the cube plus 1 the cube plus 3 into m the square into 1 plus 3 into 1 the square into m is equal to 0. We know that a cube plus b cube plus 3a square b plus 3ab square is always m plus 1 the whole cube. M plus 1 the whole cube is equal to 0. By the algebraic identity we know that a cube plus b cube plus 3a square b plus 3ab square is always a plus b the whole cube. So m is equal to, we get 3 roots. When we put equal to 0, m is equal to -1 and -1. We know that when 3 roots are equal, then CF is given by C1 plus C2x plus C3x square. So CF is equal to C1 plus C2x plus C3x square into e the power minus x into e the power minus x. C1 plus C2x plus C3x square into e the power minus x. Now pi is equal to pi is equal to, write down the RHS part in numerator, that is e the power minus x. So e the power minus x, and the function of d, that is in LHS part of the given question, in write down the denominator d cube plus 3d square plus d cube plus 3d square plus 3d plus 1. When we operate the first identity, we know that if e the power ax is given and in denominator fd is given, fd stands for the function of d is given, then we can write down e the power ax upon fa. Fa stands for the function of a, in which capital D is replaced by small a. Now we see that when minus 1 is put at the capital D, minus 1 the cube plus 3 into minus 1 the square plus 3 into minus 1 plus 1, that is 0. So it's not possible. So pi is equal to e the power minus x, and it is become d plus 1 the whole cube. D plus 1 the whole cube. We can write down pi is equal to e the power minus x is as it is upon in denominator we can write down d minus 1, it's a whole cube. Again applying identity says that if in numerator e the power ax is given and in denominator d minus a the power n is given, d minus a the power n is given, then we can write down x the power n upon factorial n into e the power ax When we apply here, we get pi is equal to x the power 3 upon factorial 3 into e the power minus x. We know that the factorial 3 is 3 into 2 into 1, so it's 6. So pi is equal to x cube upon 6, x the power 3 upon 6 into e the power minus x. Now general solution is given by, general solution is given by y is equal to cf plus pi. Cf stands for complementary function and the pi stands for particular integral. Y is equal to c1 plus c2x plus c3x square into e the power minus x plus pi is x cube upon 6 into e the power minus x. That is our final solution. I think you understand how we can solve out the given question by the using of a auxiliary equation and its identities. Now our lecture is finished. Jai Hind, Jai Bharat.